My name is Dan Marvin. I'm the TCNA Green Initiative Chairman, and I'm here to kind of introduce our speaker and also to moderate the session with some questions at the end. If you've gone to coverings the last couple of years, I've been doing a presentation on luxury vinyl tiles marketing and some of the overstatements in their marketing claims. And so people tend to send me a lot of vinyl related articles and things. And so in the fall, I sat in on one of Teresa's webinars about the health impacts of vinyl, and I was really kind of blown away. You know, I've been sort of attacking it from the technical angle of what vinyl isn't, but I didn't realize a lot of the things that she's going to talk about also go into the manufacturing of the product. So it's my privilege to introduce Teresa McGrath. She is the Chief Research Officer of the Healthy Building Network. She's had the privilege, I guess, of working in both government, non-government, and also industry. So she has a pretty well-rounded approach to her, and I think you'll find her comments to come from a place of a lot of very in-depth knowledge of the industry. During the time that she's been working in industry, it was with, I believe, Valspar and Sherwin-Williams, so a lot of that chemistry background, and then also for the EPA and some other organizations. So again, I'm thrilled to be up here with Teresa, and without further ado, I'll hand it over to you for the presentation.
Thank you, Dan. Appreciate the intro. There's a error sort of in the middle. I'm not sure. Oh, yeah. Let's see if that's better. So hopefully the little piece will go away there in the next slide, but I will be talking about luxury vinyl tile from an impact perspective. So both talking about the impacts associated with the carbon side of LVT, as well as the toxic side of LVT. I'm going to end the presentation with a bit of some stories of impact. So what are the volume of materials that we're talking about over the lifespan of a building? So I encourage you to stay for that part. I'll also be sprinkling in a little bit of material health guidance for ceramic tiles, because here we are at coverings and I couldn't resist doing that. So we're going to talk about that just a little bit as well. All right. Oh, good. It went away. So I'm with Healthy Building Network. We are a small nonprofit, remote-based. I'm personally based in St. Paul, Minnesota. We have folks all over the country and actually internationally as well. We are, my team's work, I lead the research team, and we dig into what building materials are made of, what are the human health and environmental concerns throughout their product life cycle, and we generate guidance about how to avoid the most hazardous materials and how to prefer product types that are typically better throughout their product life cycle. Our vision is that all people on the planet will thrive when the environment is free of toxic chemicals. Now, why do we focus on building materials as an organization? We focus on those because of the sheer impact and the volume of materials we're talking about. We are expected as the planet is expected to add 2.5 trillion square feet of buildings by 2060. To give you a sense of scale, that's doubling our current building stock by 2060. That's a huge amount of materials, and that's not even considering renovations of existing buildings. So this is a huge number of materials that we're going to be putting into buildings. So the time is now to get that right, to choose materials that are good for the planet from a carbon and a toxics perspective. So I'm going to start with carbon. Why do materials matter from a carbon perspective? Materials matter because of the amount of energy and chemicals used during the manufacturing of those materials. Carbon is important because carbon we refer to as carbon dioxide equivalents are a measure of the global warming potential of a particular product or a particular emission. So it's a way of measuring the impact on global warming of a particular material. And when carbon matters because global warming potential or global warming is real. It's causing impacts that we probably all know of a personal story of global warming impacting our lives or someone that we know and love. And the impacts of global warming are actually raising the temperature of the Earth at a faster rate than previously anticipated, according to the latest IPCC report. And when I talk about embodied carbon, I kind of want to start at the basics just in case some of you haven't heard that term before. But embodied carbon refers to the emissions, the global warming potential emissions that happen at every stage of the life cycle of a product, from the energy used to extract the raw materials, to the energy used to manufacture those products, to the installation, maintenance, and even that energy used to at the end of life, or the global warming potential chemicals released during that phase. It includes everything but that use phase that I have highlighted. The use phase is like the in a building, for example, is the lights, keeping the lights on, keeping the air conditioning on. That's considered operational carbon. Everything else is considered embodied carbon. Now, that use phase is not insignificant. That's a lot of energy, but everything else is considered embodied carbon. And why do we pay attention to it? The reason we pay attention to it is it's a big piece of the overall global carbon emissions story. 11%, that pie piece that we've got pulled out there, 11% of the global carbon emissions are associated with building materials embodied carbon. And actually, just yesterday, I saw an update of this statistic that shows that pie piece is growing. It's actually now more like 13% of the total global carbon emissions are associated with embodied carbon of building materials. The reason that pie piece is growing is because as our building materials as our buildings become more energy efficient, and as their grids decarbonize, our operational carbon goes down, which is great, but the embodied carbon becomes a bigger piece of that overall pie. So it's something that we need to pay attention to. Now I'm going to do a little background on EPDs because I'll be talking about those next, so I wanted to lay the groundwork. This slide is courtesy of Building Green, so they created this graphic to explain what an environmental product declaration is. An environmental EPD, an EPD is the way the industry reports embodied carbon. EPDs report a lot of other impacts as well, but we're talking about carbon, so I'm going to focus on that. EPDs are a standardized way of reporting the impacts that are gathered in a life cycle assessment. Life cycle assessments are kind of the detailed works. The EPD is the summary of all that work. The product category rule is the industry-generated document that lays out what are the rules for generating the life cycle assessment that will be used to generate the EPD. So that outlines the scope where you draw your boundaries on your life cycle assessment, what your functional unit should be, and the assumptions that you can make, amongst other things. So now I'm going to move into the next few slides. I'm going to be reporting on a report that was done by an organization called CEH. So it wasn't done by my organization, but it got their permission to share it today. And it's a groundbreaking report talking about looking at a externally generated calculation of the embodied carbon impacts associated with luxury vinyl tile and comparing those numbers with the industry reported emissions associated with LVT. The report's called Flooring's Dirty Climate Secret. And the next few slides, if they've got the little green flower on them, they're CEH's content. So I'm going to dive right into to the results of the report. Happy to answer questions on the methodologies, but always like to dive right into what did we find. The findings from the report, one of them was that 90% of the flooring sold in the US is coming from China. And this was relevant because the manufacturing process of vinyl chloride monomer is different in China than it is in the United States. There's different ways to make this vinyl chloride monomer. One is the ethylene-based process, which is what's typically used in the United States, and one is a coal-based process, which is what's typically used in China due to the availability of coal in China. As everyone probably in this room knows, the vinyl came out into the market in the early 2010s and has just exploded in the marketplace. So now it represents over 20% of all floorings installed are a vinyl product of some sort. And majority of that is coming into the United States from China. So that'll be an important detail in a couple slides. For this report, we've focused on what's called the A1 through A3 stages of the life cycle. And there's a few reasons that that CEH focused on those stages. One, that's what the industry industry EPD reported on. So we wanted to compare to that industry EPD, so we chose a similar scope. The second was that's really where all the impacts lie. That's where 90% of the story, the carbon story for luxury vinyl tile, is in those A1 through A3 stages, which is similar to many products. Many products have the majority of those impacts lie in those early stages. All right, here are the findings. So first, on the left-hand side, we have the industry-reported EPD. The industry-reported EPD reports 12.8 CO2 equivalents for square meter of flooring. So that's what's reported in their industry-wide standard. Now, when we look at the US-based plant, CEH chose a typical manufacturing facility and focused in on reporting for that facility. They chose this particular plant because it was a moderate size, or in the median in terms of production volume, and it used the typical process of the ethylene-based process that's used in the United States typically. The reporting was about 1.3 times higher than what was reported by the RFCI's Environmental Product Declaration. So that was in the U.S. process. When we move over to the China-based process, again, CEH chose a moderate-sized manufacturing facility. They chose the manufacturing facility that used the ethylene-based or the coal-based process because that's what's typically in China. And that report showed that the emissions were 2.7 times higher than what was being reported by the RFCI. And remember that 90% of the flooring coming to the U.S. is coming from China. Do you have a question? Yeah.
I did. So if the typical in the U.S. is there and the typical in China is there, why would industry standard be so low? What are they using as an average comparison?
Yeah, so the explanation for this is probably multifactored. So part of the explanation for the industry standards is unknown because the Environmental Product Declaration doesn't have that level of detail. So we don't know exactly, but we know they're probably assuming that they're using the ethylene-based process. They're probably assuming it's being sourced, that the majority of vinyl tile is being sourced from the United States, which of course is incorrect. There's probably some scoping differences as well. The CEH report noted that the EPD was drawn at the process of the manufacturing, so they didn't consider the chlorine manufacturing or vinyl chloride manufacturing impacts in the total of impacts of the manufacturing. As it was not my report, I can't comment on that any further. That's what was available in the report. But there's probably a lot of different slicing and dicing that's happening to get a more favorable number there. Either way, it appears to be incorrect by quite a bit. And so the next steps for that, what do we do about this? I think there's a few things going on at the Tile Council that's addressing this from an FTC perspective, but it would be holding the companies accountable, the trade associations accountable, and the verifiers. So there's folks who verify environmental product declarations, and it's their job to make sure that those numbers are being reported correctly. And so it would be holding them accountable as well. Yeah, good question. Any other questions on this? Great, thank you. I'm going to skip over the next couple slides. Happy to go back to those, but I wanted to make sure we have time to talk about why materials matter from a material health perspective as well. So I'm shifting gears away from carbon, but we'll bring it back. So from a material health perspective, I'm going to talk about why we care about materials, and there's lots of reasons, but one of the big reasons we talk about is that we as people spend 90% of our time indoors, and another 5% in cars, which is a little depressing for me, but the indoor air tends to be more polluted than outdoor air, 2 to 5 times more polluted in some cases. In fact, I've heard from indoor air specialists or air pollution specialists that is a friend of mine that they consider indoor air as a point source of pollution for outdoor air. And that's where we're spending all of our time. The materials that we use in our buildings make their way into our bodies. We know they do. They do that through the air that we breathe. They do that through dust. The materials that are in our buildings migrate out and make their way into our bodies. And we know that because we know we are measuring biomonitoring. This is just one sort of age study at this point, but US babies are born with over 200 industrial chemical pollutants in their bodies. And that's before they're born. They have this in their bodies already. And these are chemicals that can impact our development. They can they can lead to cancer. They can lead to long-term health effects. And there's also a connection with toxics and climate. So we talk a lot about embodied carbon, but toxics have a role to play in climate as well. There's some direct impacts. So some building materials use high global warming potential chemicals in their manufacturing process or in the products themselves. If you're, an example is HFCs and spray foam insulation. Those are going to have direct impact on our global warming and the overall carbon dioxide equivalent story for a product. We also have there's increased vulnerability in communities that are near manufacturing facilities as we have increased natural disasters, fires, hurricanes, floods. Those are all going to be, the impacts of those are all going to be worse when you bring toxic chemicals into the equation. If there's a facility or manufacturing facility using toxic chemicals that are released during those disasters. So that's going to impact those communities in a much higher way or much bigger way when those toxic chemicals are released. In addition, we've got More efficient buildings, so we've got tighter buildings. The new building stock is going to be all more energy efficient, tighter buildings, and so we have to be more considerate of the materials and the chemicals that we're trapping inside, and in a different way than we had to before. So those tighter buildings can trap those materials and increase the exposure to the occupants of those building materials. All right, I'm going to talk a little bit about a tool that HBN has developed. Healthy Building Network developed a tool that's called Informed, which is our product guidance. So it's our guidance, our simple guidance that that product selection teams can use to choose typically safer materials, again, from that material health perspective. Think of it as a modeling tool that you can use early in the design process, similar to energy modeling, that can help point you directionally towards product types that are going to meet your sustainability goals. When we generate our guidance, we look at the impacts throughout the life cycle, just like embodied carbon. We look at the impacts associated with the extraction, refining, manufacturing, installation, all through the end of life. So we care about, if we call a product safe, we want it to be safe for the fence line communities at the manufacturing facilities, all the way through to the fence line communities at the recycling facilities or at the end of life, where those products will end up at the end of life, and everywhere in between. When we do our research, we start with understanding what are the chemicals and materials that are typically present in those building materials, and what are the human health and environmental concerns, both with how they're made and how they're made and what happens to them at the end of life. And we look at the chemicals and materials that are needed to install those products, to maintain those products. We look at the end of life of those, the length of life of those products. How often do they need to be replaced? We consider all of these factors and normalize them to a 1 to 7 scale to compare a particular product type within its product category. When I say product type, I mean like a carpet material or a ceramic tile or a linoleum. Those are product types within the larger product category of flooring. So I want to compare the product types within their product category. This is an example of our guidance for flooring. And so you can see we have all types of flooring in here, including carpet, tile, ceramic tile. LVT is in here as well. And what we encourage is to avoid products in the red zone. Those are products that are worst in class from a material health perspective, and prefer product types in the yellow and the green zone. Those are product types that are typically safer throughout the product life cycle, and all the metrics that we look into. You'll notice that this talk is about PVC, so I'm going to talk about the PVC impacts. PVC is present in a couple places on the spectrum, all in the red zone. They're in the red zone because PVC uses hazardous chemicals throughout its life cycle. Specifically in the manufacturing phase, it uses to generate the chlorine that's needed to generate the vinyl chloride monomer. They're using mercury, they're using PFAS, which is a persistent forever chemical. They're using asbestos. All of these are chemicals that are hazardous throughout their product life cycle. So even a best-in-class vinyl product, if you find a specific manufacturer that's best in class for vinyl, it's still going to be worse than our product types in the yellow and green zone. So we encourage people to use this product type first approach to select a flooring product that's going to point you directionally towards products that are safer. You'll notice our guidance doesn't point out specific manufacturer data. We are leaving that to the certification folks. We're trying to point people towards product types before you land on a specific manufacturer, towards product types that are going to meet your sustainability goals. So in yesterday's talk, if anyone of you were there, I apologize for being repetitive, but we used the grocery store analogy. My boss really likes to use this analogy because if you're in the candy aisle, for example, you know that whatever candy you choose, it doesn't really matter. Whatever candy you choose, it's probably not going to be the healthiest choice for you. It's probably not going to be the best option. If you're in the vegetable aisle, you're probably going to be choosing whatever you land on. It's probably going to be a fairly healthy option. So what our guidance is trying to do is, if you're you're at a flooring store, we're trying to point you down the aisle that's going to be generally better from a material health perspective. We have this guidance available in 2 different formats at the moment. One is a more analog version that's available on our website on healthybuilding.net. We have 13 different product categories at the moment. We're adding categories all the time to our guidance. And each one of these you click in and you would see a similar red to green guidance of different product types within that product category. We create a new continuum of improvement for each product category. So for example, the roofing products are gonna look different, or what's a yellow for roofing, yellow and green for roofing, might be an orange and red for flooring. So each one we looked at what product types are available and created a new continuum of improvement within that product type. So this is one way to access it. Again, healthybuilding.net for that guidance in our product guidance. Another way is a brand new tool that we released on Monday called our Informed Product Explorer. This is at informed.healthybuilding.net. And this, we think this is an interactive tool that project teams can use early in the design process, and we think it fits really well into the project flow. So we worked with an architect to help design this, and it's organized by master format code. So it really fits into the way specs are being built early in that design process. And it provides real-time feedback for your choices. So if you happen to land on vinyl tile, I don't have the example up here, it will yell at you. It will say, this is not a good choice for these reasons. You can do better. There's lots of other better options available. Take a look at these other options. If you must choose vinyl tile, here are some things to do. Here are some ways to improve within that product type. So we give both guidance on how to make a leap up towards safer materials or take steps within those materials to make better choices. Yeah.
Back up the last slide.
Sure.
I'm sorry, another one.
One more?
Where you put linoleum at the very top.
Yes.
Can you talk more about why linoleum is at the top?
Yeah.
Than wood?
Yeah, so I would say that the ordering within the color is probably not as important as the color shading itself. But linoleum is near the top of our spectrum for a couple of reasons. It has a lot of bio-based materials in it. It lasts a long time. The fillers tend to be bio-based in addition to the linseed oil resin that's in the material. And the life cycle of it or the lifespan of the material is longer than other materials on the spectrum. Yeah. So yeah, there's a lot of different factors that go into the rankings. And within each bucket, there are ways to improve within each. I'll talk in a couple slides about ceramic tile, for example. You know, it's in the green zone, but we can improve even within that.
What was the life cycle for the remember what it is?
I don't know off the top of my head, no, sorry. In terms of the service life?
The TCNA just literally this week setting up their life cycle analysis.
Yes, I was speaking with Rick yesterday, and I just sent him a note right before this to send me that report because I'm very interested in seeing that. So thank you. Yeah. Yes, thank you. So we're learning, as we learn more, we update our guidance. So these are not static. We update them about once a year, and things shift around. We add materials, things move, and as we add materials, we learn more about the continuum of improvement. And if that shifts, if there's a new definition of dark green, for example, then everything else will shift too. Yeah, good question. Any other questions before I move on? Thank you. Oh, yes.
Sorry. Just to get back a little bit, you brought up the fact that, we have all of these toxins in our homes that spend 90% of our time in there, we are comforting tighter, but what exactly from vinyl flooring are we concerned about as far as toxins go?
Yeah, there's a lot of life cycle impacts associated with vinyl. So during manufacturing, we've got the fence line communities being exposed to materials from the fence line or from the manufacturing. So that's your asbestos, your PFAS, mercury emissions from the manufacturing. You've got during the product use, that's probably where we're, of all the stages where we're least concerned. They used to use phthalates, and there's still some manufacturers that use orthophthalates in vinyl flooring, but majority of the industry has moved away from that orthophthalates in vinyl flooring. So that's an improvement. So you'll see it's sort of cut off on the slide, but the orthophthalate-based vinyl flooring is going to be in the dark red zone, whereas orthophthalate-free is in the light red zone, or the red zone. And there's also some tin stabilizers, organo-tin stabilizers in the vinyl flooring itself that we're concerned about during the use phase. End of life, we're also concerned because there's not a current good recycling program for vinyl flooring. So it tends to be either landfilled or burned, and when it's burned, it also releases hazardous chemicals like dioxins. And I'll get to it in the last slide, but throughout the product life cycle, there's opportunities for exposure, and the train derailment in East Palestine is one good example of that, where vinyl chloride was being shipped, most likely to be turned into a vinyl building material of some sort, and that train derailment caused the spill of highly carcinogenic and toxic chemical in a community. So at every stage, we've got different impacts. Does that answer your question? Okay, thank you. Great. Excellent. So I wanted to spend just one slide on ceramic tile. As I mentioned, within those buckets, those are generally going to be, better choices, but we can improve within a product type, and there's ways to improve. So I wanted to spend just one slide on ceramic tile and how we can improve. One way is to make sure that the tile is lead-free. The industry has done a great job of transitioning away from lead in ceramic tiles, so majority of the products in the marketplace are going to be lead-free. But it's still a question, if you're not sure where your tile is coming from, it's still a question you should ask, and something you should confirm with your supplier. So let's move on to accessories. Grout, need grout for tile installations. So from a material health perspective, we prefer cementitious grout over epoxy grout. The reason for that is the presence of bisphenol A, or BPA, in epoxy grout. It's probably more a concern for installers than product users, but again, we care about we want to make sure they're safe for everyone. Bisphenol A is an endocrine disrupting chemical. It mimics the estrogen in our body, and So that's a reason that we'd want to avoid epoxy grouts if possible. Now, that's not always going to be possible, but where you can. Moving on to sealers. The big thing I want to point out in sealers is the use of fluorinated chemistry, or PFAS, in sealers. So if you can, avoid sealers altogether. That's an easy way to avoid PFAS. If you can't, if you need a sealer for waterproofing purposes, for example, or water-resistant purposes, then just make sure, ask the supplier if the sealer is free of perfluorinated chemistry or PFAS. They should know the answer to that question, and there should be alternatives available. There are alternatives available. One indicator of PFAS is if the sealer is advertised as oil repelling. That's a good indicator that that sealer contains PFAS.
I have a question.
Yes.
Are these to be avoided at user stage, or once they're cured and they have embodied into whatever you put them into, they become inert? Then is it okay? Or?
Yeah, good question. So for it depends on which one you're asking about. For the BPA, for example, I think the biggest opportunity or the biggest concern stage for BPA is both in the manufacturing of bisphenol A as well as the installing, because that chemical is not reacted at that point while the installers are putting in the grout. Once it's cured, the potential for exposure to the user goes way down, especially if it's sealed after that, it goes way down. But I guess you don't seal epoxy grout typically, so ignore that. But that's typically where you'd see the biggest opportunity for exposure is in the manufacturing and installation stage.
The reason I ask is that, at a tile show, when I see that sort of concern, and I see your point about LVT, but that I see that probably not being as well received by some people at a tile and stone convention with that state. It's scary to see.
Well, I'll take blame for that one, Martin. When we talked about putting together this presentation, I asked her to include a slide on what the tile industry can do better. Again, kind of go back to her point that you're talking about the green category, some kind of low-hanging fruit to do better in our part of the world versus a deep red category where it's really hard to do much good in that category. So I'll take blame for this one.
Yeah, we want to encourage everyone to take steps to do better at every stage. So these are a couple of actionable steps that can be taken to avoid some chemicals of concern that we've identified. Mm-hmm. Right. Good question. Any other questions on this piece? Okay. Excellent. Okay, I'm going to skip over this one because we kind of already talked about it. So, to wrap up the material health side of the conversation, we encourage project teams to think about material health early in the design process. Informed can help you do that, or product guidance can help point project teams towards product types that are going to be typically safer. What's really exciting also is that product types that tend to be yellow and green on the we call our spectrum, our red to green guidance, also tend to perform well from an embodied carbon perspective as well. There tends to be a lot of overlap in product types that are typically better from a carbon and a material health perspective. Not always, but that's typically what we see. Once you've kind of honed in on a product type that is best in class and works for your project, then you can refine and choose the best product type within that category, the best ceramic tile, for example, by looking at certifications, using certifications that meet your project team's sustainability goals. So I'm going to move, the last section of my talk is talking about stories of impact. And I'm going to pick on plastic for a little bit because this is a PVC presentation. But I want to give some sense of the impact the volume of plastics that are going into and coming out of our buildings every year. I'm going to start with carpet as an example. Carpet is a plastic product, or primarily a plastic product. The carpet industry itself reports that about 2 million tons of carpet is discarded in the US every year. About 60 to 70% of that is plastic, so that's 1.2 million tons of plastic that's discarded every year from carpet. Carpet has one of the most sophisticated and developed take-back programs of building products, and even with that, only a little less than 0.5% of carpet that's discarded is taken back and recycled into new carpet. So it's still in its very infancy in terms of a circularity story. We celebrate that, but it's still a long way to go. So let's put 1.2 million tons of plastic in perspective. That's equal to the amount of plastic that's discarded every year in the US in terms of the number of bottles, plastic bags, and plastic straws put together. And that's just one building material. So the plastics story for buildings is on the same scale or magnitude as single-use plastics. And that's a challenge. So let me talk about a couple of ways to take a step up, and we'll talk about ways to take a leap up. So the first example is a small step up. Let's move from the red zone to the orange zone. So red with carpet with vinyl. Vinyl shows up in carpet as well as the backer in carpet. So there's carpet on the marketplace without vinyl. So let's encourage project teams to take that little step up if they're not ready to get rid of their carpet. By taking that step up, we can avoid 1.9 tons of PVC plastic in one building, one application of carpet. And again, this is avoiding those fence line impacts from the mercury, asbestos, and PFAS that's used in the manufacturing of PVC. So that's a step up. Let's talk about a leap up. Let's talk about replacing that carpet with ceramic tile. What happens then? And when we talk to our partners about getting rid of their carpet, it makes them very nervous. So let's just replace half of it. So half of the carpet with ceramic tile. What does that look like? We used an assumption that from feedback from our partners that they're replacing carpet in their office buildings every 3 years, which was a surprise to me. So that translates to, over the course of the life of a building, let's say a building lasts 50 years, that's a lot of turnovers of that carpet material. If we replace that carpet with 50% of it with ceramic tile, in one office building over the course of that building's life, we could avoid 100 tons of plastic over that building's life. That's a stunning number. Now let's multiply that by all just office buildings in the US. That's 33 million tons of plastic over the course of that product life. That's just swapping half of that carpet out. So I think this is really important for us to think about how we can avoid that plastic waste by choosing product types that are not plastic to begin with and that last a long time. Again, I mentioned I was going to bring this up, so I was going to land on the story of impacts for how this shows up in real people's lives. So we all have seen the East Palestine story of the vinyl chloride, the trains full of vinyl chloride that crashed in Ohio. And so wanted to just land on the idea that if those were being, shipped because there's demand for PVC products in this country. So this is being shipped to manufacturing facility to meet that demand. If there was lower demand for PVC, if there was higher demand for other products, let's imagine for a moment that those trains were filled with clay destined for ceramic tiles, or copper destined for copper piping, or wood destined for wood siding instead of PVC building materials. The story, we wouldn't have even heard of this story. The impact on that, the train might have still crashed, but the impact on that community would be much, much different because you're not shipping around hazardous chemicals around the country. So that's another example of like a fence line impact or a life cycle impact associated with vinyl. I think that's where I'm going to end right now. So I'm going to skip this last way. Yeah.
All right, well, we are going to take some questions, but first I had one for you. I know you're taking on basically the whole plastics industry with your presentation. Are you getting some traction with it, or what are your challenges and what are your successes so far?
Yeah, it's a great question. It's challenging. It's challenging to get people to see the use of plastics in buildings as on par with the single-use plastics. So even our organization is largely philanthropy funded. So even the funders that we're talking to, getting them to get excited about plastics and building products is challenging, to get them to pay attention to it, to see it as a challenge. I think they're thought about and they're talked about as durable goods and as goods that last. The estimate that is being used in all of the larger analyses of plastics is that plastic products last for 35 years in buildings, plastic building materials. And with the exception of maybe insulation, I can't think of another plastic material that's going to be lasting that long. So I think those assumptions are off. So I think we need to rewrite the narrative in terms of how often these materials are actually being replaced. Sometimes it's not even because they're wearing out, it's because they're aesthetically no longer desirable. So sometimes they're being swapped out earlier than their service life for that reason. So I think we have to really understand how often these materials are being swapped out and why, and what the volume of plastic waste we're dealing with.
I see that with tile because its lifespan is never realized because of remodeling, tenant improvements. And so even though we have a product that lasts much longer, it's never realized that the product's lifespan is never realized because it's taken out much too soon. And so I think that's the counter argument to what you have right there is the products may last longer, but they can never meet that potential.
Yeah, that's a great point. And so I think there's there's a question of, how's education, consumer education used to install products that are, aesthetically more neutral, that are less likely to be swapped out over their life cycle, or finding opportunities to swap those out. The life cycles, or the assumptions we made for our calculations assumed, even though it can last for 50 years, we assumed that it was being swapped out every 10 years just to be conservative.
But pink bathrooms are making a comeback, so hopefully we can get that 70-year lifespan.
Yeah, right.
I just think that other soft goods are used because they are easy to replace and disposable, and that it's just an easier choice. Cost, I mean, and until we start getting that into people's mindset, it's going to be very difficult because it's all mainly cost-driven.
Mm-hmm. Yeah, there's a lot, when you're looking at luxury vinyl tile, there's a lot of reasons why it's one of the most popular flooring in the U.S. It's cheap, it's aesthetically pleasing, it can look like wood, and it's easy to install. So all of those are things that are going to be a challenge when you're trying to encourage people to phase away from. We work a lot with the affordable housing sector, for example, and in multifamily homes, it's almost 100% vinyl at the moment. And so how do we encourage project teams to see over the lifespan of the material that those costs are going to be higher. Or how do we account for all the pollution costs throughout the product life cycle and bake those into the cost of the product?
I really appreciate you bringing this and making people aware. I'm a product of the 60s, and I had lead in the gas, in my pencil, exposed to vermiculite, asbestos, everything. I'm amazed I'm still here. But we weren't even aware it was a problem back then. So having this awareness out there and having people, made, so there's more transparency is really good. Thank you.
Yeah, thank you.
Dale?
I just experienced this a couple weeks ago. One thing you might want to take into consideration is the global warming now. And if you just look at what happened in Fort Lauderdale, up in Montreal, we had 600,000 people without power for like 3 to 5 days. So in my case, I have a sunk pump. I had a battery backup, but it doesn't last 3 days. And so I had a little bit of water, and shame on me, I don't have tile in my basement. It's to be done soon, hopefully. But the reality is that that's the other part of the equation that really should be taken in, is that with these, natural, phenomena that's occurring now with flooding and what have you, tile is such an easy way to be able to avoid having to, another friend of mine lives right across about 2 blocks away from my place, had 6 inches of water, and her basement is her living area because her mother lives upstairs. And she had engineered wood. All that engineered wood had to be torn out. It was already molding on her. The drywall has to be cut up at least a foot because of moisture penetration. Now, if they had put tile down there, and I gave her heck and said, look, spend a little bit more money, put tile in this time. You can wrap up the base with waterproof membrane, and for all intents and purposes, unless it's really high, little incidents of that will definitely not be an issue. And again, the whole life cycle aspect. But I think now with the way weather is going, this is our new reality. I know in Montreal we are expecting more and more of this type of, we had an ice storm, and that ice storm knocked out power lines, and trees were falling everywhere and what have you. And that seems to be all over the place now. It's, look at California. What was, they had snow in Hollywood, for God's sakes. So I think it's another part of the equation that should be actually probably exploited by us in the tile industry, because when you go and you look at what the cost is to tear this stuff out, and then the other thing is how much mold penetration actually was in her wall cavity. I told her, you better get a specialist to come in and check it all out, because if you got mold in there, all you're doing is just making yourself sick, because it's going to obviously get into your airborne air within your living area. So.
Well, and these are all stories that the tile industry has to do a better job, I think, telling. Okay. We've Coverings is a great place to kind of give you the tools to go out and be the evangelist for tile. And in Teresa's presentation is there's some great takeaways there. You can talk about the health impacts of vinyl flooring, which is, we're in a war with vinyl flooring for floor covering space. So definitely everything you just mentioned is accurate. All the takeaways we have from this presentation, now it's kind of all up to all of us to go out into the field and tell that message. So absolutely.
Yeah, and I would just add that floods are a great example, fires are another. It's a really different situation when a plastic building burns versus any other, mineral or wood-based building. It's very different in terms of the number of emissions that those firefighters are exposed to. So that's another angle too that we talk about and work with. Work with the firefighting industry to try to build awareness there.
Kathy, did you have a comment? I saw your hand up.
We know that a lot of the vinyl now is moving, they're saying they're moving away from PVC. We don't know. That 90% is being made in China. You're saying 90% is being made in China. We really don't know what's in those products. So they may have PVC, they may not. But if they're being legit and they're moving away from PVC, they're obviously putting other plastic in to replace it. Have you leaped ahead and started looking at the consequences and what
that might be entailing in terms of human health and planet health, these new plastics they're putting in, or different plastics?
Yeah. So there's some PVC-free resilient flooring options out there, and there's a variety of polymers that are being used or plastics that are being used. Polyurethane is a common one, and that is not preferred from our perspective either, because it actually shares a lot of the same feedstocks as PVC. So polyurethane, yes, it's PVC free, but it's still not preferred when you look at the life cycle impacts of that material. We've seen some like polyethylene, PET products, and other plastic materials that are better from when you look at the full life cycle of that polymer, because they're not based on that chlorine chemistry. So that's a big distinguishing feature. The polyurethanes and PVCs all use the chlorine during the manufacturing process. And so those halogenated materials are just so impactful. So there are some better plastic materials, but they're still plastic. So still never going to be like the most preferred from our rankings. Yeah.
This is a good conversation to start with, but as a remodeler all around, the challenges that I see is, so what's, as it was discussed, tearing up ceramic tile has all of the ramifications of the dust and all of that deals with the weight and the disposal, which putting LVT on top of ceramic to take care of that is one solution. But then there's the whole shower bath problem, particularly in this market in Central Florida, where builders are putting drywall in and they're putting ceramic tile on top of it, and then they wind up with mold and mildew. The end user has that, and you have all of that you're dealing with inside the house. And so, like, what are the worst parts? Because the new products that are out for substructure are now all plastic based or all PVC or whatever based to take care of that mold and mildew situation. So which is worse?
No, typically those aren't PVC based. The membrane products tend to be PET or a different chemistry that doesn't involve the chlorine. It's just a small correction there.
Right.
But,
okay.
But to your point, there are end of life concerns with all these materials, and nobody's perfect. I think what we're trying to do is give you some ammo. I did do the presentation last year on the marketing of vinyl, and they really get into a lot of areas where they're maybe overstating their benefits. So we're just trying to kind of give it a reality check to all these claims.
Yeah.
I know we're keeping you from lunch. Maybe another question or two here,
question
and we'll
back
stick
here.
around after.
I just actually did want to clarify about PVC-free resilient flooring, because that was on your list in the yellow. So would that also be like SPC and WPC floors? What would be in that category?
Yeah, so the wood plastic core would be, if it has vinyl in it, it would be in the vinyl category. Or either any of the engineered woods or engineered products. If there's a vinyl core, we would consider that in the vinyl category for all the life cycle impact reasons. The PVC-free resilient flooring. So that was, if you went under our website, it's further defined what that scope is, but it is excluding engineered wood, cork, polyurethane flooring. So it's focused on more the polyethylene type. There's a few different plastics that are rolled up into that. Does that answer your question?
Yeah, and I can look on the
Okay, thanks.
Maybe one more. I think there was a question over here.
Yes.
Thank you. So this gentleman said we should expect this to be our new normal. It's a shame to believe that we should accept this as our new normal. But in a capitalist society, right, and your slide showed that we're getting 90% of this material from China. Unfortunately, it's allowed. So we're sitting on a situation where it's cheaper, it's easier to install, it's easier to remove, it's easier to dispose of. So this is kind of grassroots. How much impact do you think this is going to have when you're dealing with developers that want this material to go in $1 square foot, and you can talk to your blue in the face, especially like you said with HUD, they're 100% vinyl. So how do you go about changing the 90% to something less than 90% through government regulation or some kind of consciousness that isn't occurring right now?
Yeah, it's a good question. I'd pose that to anyone in the audience who wants to pipe in on that. I don't know that I have the answer. We can, our approach as an organization is to, our strategies are to build transparency. So just bring awareness to the issue at hand, and to work directly with buyers to educate them. So that's going to be the big property owners, that's going to be the affordable housing developers, that's going to be the architect firms, and the remodelers, and trying to provide education and awareness for moving towards alternative materials, alternative flooring options. Now, with all that work, the use of vinyl continues to grow. So we can't do that alone. We're not our organization is not policy focused. We're a research organization, but we partner with folks that are policy focused. Because I think you're right, it's going to take a multi-pronged approach, and building in some of the costs associated with the environmental and human health impacts into the cost of the building product is going to be critical, a piece of that. I think extended producer responsibility is also going to be a critical piece, and that would apply to all manufacturers. But we're, to have responsibility about what's going in your product and where does it end up at the end of its service life, I think is also going to be an important piece of the puzzle. But I'm also open to ideas and open to hearing from anyone in the audience on what you think might be a solution. Sorry, I don't have a better answer for you. Tariffs would be another. Yeah. Probably not, yeah.
Government purchasing, if you sat in on yesterday's session that Teresa was a part of, they talked a little bit about all the funding that's out there for using green materials and trying to get the EPD concept sort of baked into the government purchasing scheme. So, there are efforts to, kind of stem the tide a bit, but until it becomes a dollars and cents issue, I don't know that we can say that it's necessarily going to crest.
Yeah. Yeah, that's a big challenge. You know, and when I, at least as an organization, since we are, 16 people, we have to focus our resources. And so the way we focus is on, as opposed to individual consumers, we're focusing in on the retailers or the big property owners to try to shift the tide there, because it's a smaller audience for us to work with. As if the retailers can, educating the retailers, they can shift what's available on the store shelves, then the consumers are going to have hopefully better options to choose from in the store themselves. And so we think that's a strategy worth pursuing, and that's helped in other areas. For example, in paint, the Home Depot avoided or required all their suppliers to get rid of it's another endocrine disrupting chemical called alkyl ethoxylate. So they wrote it into their supply chain, into their supplier agreements, that all the paint that's on their stores, free of alkyl. So most consumers don't know that word, don't know what it means, doesn't care. But if they go into the Home Depot, they will not choose a paint that has it. They'll choose a safer paint. So that's been our strategy. I think, again, it has to be multi-pronged, but our focus is on those bigger buyers at the moment.
Well, our time's about up, but I think Teresa and I are willing to come up and approach us and ask any other questions you have. But until then, thank you very much for attending, and we hope you enjoyed the session.
Yeah, thank you.